Covalent nomenclature. Let's do it. So covalent or molecular compounds contain only nonmetals, and we name them completely differently. Covalent compounds do not have charges. We're going to learn in the bonding unit that they share electrons. And since they share electrons, no charges, if there's no charges, you can't build the formulas because you don't know how many to bring together. So we have to use the Greek prefixes to say how many of every element there are. When we name covalent compounds, it starts out similar to binary ionic nomenclature. The first thing you do is you just name the first nonmetal. You don't change its ending, you just name the first nonmetal. And then, like binary ionic nomenclature, you change the ending of the second nonmetal to "ide." But here's where things are like sodium chloride, right? So you name the first element sodium, you change the ending of the second element to "ide." But now I'm going to have two nonmetals, okay? Whereas like sodium was a metal. Here's where things are going to be different. And now what you do is you state how many of each type of element there are using these Greek prefixes. You need to memorize these Greek prefixes. Now, the good thing is that once you get to tri, it's very similar to triangle or to, to geometry, like triangle, tetrahedron, pentagon, hexagon, heptagon, octagon. So you got to memorize these. Our prefix for one is mono, prefix for two is di, tri, tetra, penta, hexa. Everybody always forgets seven. 7 is hepta, octa for 8. Everybody always forgets 9. 9 is nona or nona, and then 10 is deca. And now we have some other little side notes here. You never use the prefix mono on the first element. Never use prefix mono on the first element. And sometimes we drop a vowel. If our element starts with a vowel and our prefix ends with an A or O, you drop the A or O from the prefix. So like if it was going to be tetraoxide, we drop the A and it'd be tetroxide. Okay, so if the element starts with a vowel and the prefix ends with an A or an O, we're going to drop that. And a lot of people do that kind of automatically. So if you don't take a second, if you don't have that memorized, jot that down or take a picture of that. Get that memorized. I'm gonna put a couple on the board. We're gonna practice and try this. Most people, this is like, oh my God, this is so much easier than ionic. All right, let's do this thing. We're getting there, folks. It's 9:07. We're doing this. We're doing this. So all of my elements, hydrogen counts too. All of my elements are above that staircase for hydrogen. Okay? CO2. You all know that's carbon dioxide. What did you just do there? Well, first of all, carbon, oxygen, both above the staircase, right? What do? We name the first element, carbon. We change the ending of the second element to "ide," oxide. And now we put prefixes on, except if there's only one of the first element, we don't use the prefix mono, we just drop it. So we don't say monocarbon, we just say carbon. Prefix for two is di, dioxide. Another one you probably are familiar with, CO. Carbon, oxide. If there's only one of the first element, we don't use a prefix. I only have one of the second element, I do use a prefix, so mono. But since that begins with an O, I don't say monoxide. I drop the O from mono. It's carbon monoxide. Carbon monoxide. Give me another one. N2O5. That's nitrogen. Oxygen becomes oxide. I have two nitrogens, so now I'm going to use a prefix, dinitrogen. My prefix for 5 is penta, but that starts with a vowel, so instead of pentaoxide, it's pentoxide. Dinitrogen pentoxide. Give me another one, then I'll have a whole list, don't you worry. Yeah. P3Cl7. Give that guy a shot. So we got triphosphorus. Heptafluoride. I get a lot of septas. Septa's the light rail in Philly. You don't want that. Hepta. Let me put a bunch up here. You give them a shot. Try these. We actually just did number 1. Try those. Give me the names. You got this. Here we go. We did number 1. Carbon dioxide. I wonder if I can. What are the odds this is going to work? Let's get crazy. So number 2 is going to be dinitrogen tetroxide. So it's tetraoxide, but it becomes tetroxide because you drop the A. Number 3, that is xenon tetrafluoride. That's the first compound they ever made with a noble gas. People are very excited because noble gases are very inert. They don't like to do anything because they have a full octet. So that was our first noble gas containing compound. Number 4 is sulfur monoxide. Number 5, phosphorus pentachloride. Number 7, heptanitrogen trifluoride. Number 7, dihydrogen monoxide, but I just call it water. There's a couple years ago, probably about 15 years ago now, some kid in California did a science fair project where he had people sign a petition to ban dihydrogen monoxide. And he got like a ridiculous amount of signatures, and everything in the petition was true. Like, overexposure can cause death. Well, yeah, you can drown. Is an acid and a base, so it's amphoteric. And anyway, so anybody will sign anything if you just promise to get away from them. So oxygen diiodide. I don't drop the I here because the prefix doesn't end in an A or an O, so I do diiodide. It sounds weird, but and then finally number 9, that's carbon tetrabromide. So hopefully that went awesome, man, and boy, covalent nomenclature is way easier, right? We learned how to do that in about 10 minutes, whereas the ionic nomenclature took like an hour and a half. Still, you should be impressed. I mean, you learned a whole language here in like an hour and a half. It's like not bad at all. We got a couple things to tie up here, and then acids. Molecular elements. I don't know where else to put this. There are 7 elements that come as diatomic species on Earth, and you should memorize them. These are going to be really important when we get to the gas chapter, the gas unit, because 5 of the 7 are gases. So here are the 7 elements that, like when I say oxygen, you should know I'm talking O2, because monoatomic oxygen, just O, that is not stable. So the 7 diatomic elements are Brinkelhoff. Some chemistry teachers do Hinkelbroth, but I'm a Brinkelhoffer. So that's bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Here's what is important, okay? These 7 elements always on Earth are paired up. So if I have pure bromine, it's not Br, it's Br2. If I have pure oxygen, it's not O, it's O2. So, 70% of air is nitrogen. That's not N, that's N2. These elements are just only stable when they're combined in a diatomic fashion. If you're a visual person, okay, it's kind of creepy. There's 7 of them, and they like make a 7 plus hydrogen, right? Yeah, but they make a 7 on the periodic table. I don't know. Weird, right? It's like freaking me out. So make sure, like, familiarize yourself with that. When I say chlorine, that's Cl2. When I say fluorine, that's F2. That's gonna be important when we start doing stoichiometry. If you only use the mass of one fluorine, but fluorine's F2, now we got problems. So the last thing we need to cover is acid nomenclature, and then we did it, and it's only 9:18. Oh my goodness. Woo! The acid nomenclature is going to do on the board here. I'll give you some examples, and then one of the activities is on it. You guys should be all right. We don't really cover acids until Chem 102, so it's not super important, but you're going to interact with acids in the lab, so we should talk about it. Acids can be, so this is acid nomenclature. Acids can be broken up into binary acids and ternary acids. Binary acids. So first of all, acids, they all have a formula H something. So what makes something an acid is it has a hydrogen that can dissociate and form H plus ions. So a binary acid is literally, as the name suggests, bi, two. That's a hydrogen and like one other element. So some examples that would be like HCl, HF, H2S, HBr, HI, whatever. HCl. No, we got that one already. H3P. Those are binary acids. Acids, hydrogen and one other element. When we name binary acids, we use the prefix hydro. We change the ending of the element to ic, and we throw the word acid on the end. So, for example, HCl, that's hydrochloric acid. HF, hydrofluoric, fluorine goes to fluoric acid. Sulfur and phosphorus are a little special. To avoid awkward pronunciations, we put the back in sulfur and we put the or back in phosphorus. So hydro sulfide, we go sulfuric. We don't say sulfic, we say sulfuric. Now, most people just do that naturally because it sounds better. So sulfur and phosphorus, bit of exceptions, we put the and the or back in. So that's hydrosulfuric acid, hydrobromic acid, hydroiodic acid, hydrophosphoric acid. So there's your binary acids. Ternary acids are going to be hydrogen and a polyatomic anion. And here's what we do. We do not use the prefix hydro. That's the main thing. No hydro on ternaries. If the polyatomic ion ends in "ite," you change the ending to "os" and throw the word acid on there. And if the polyatomic anion ends in "ate," we change it to "ic" and throw the word acid on there. I'll give you some examples. So, for example, Here we have an acid that's got polyatomic ions. Now, if you look on your sheet, NO2 with a -1, that's nitrite. NO3 with a -1, that's nitrate. So nitrites, the ite gets changed to us, so nitrous, and then acid. HNO2 is nitrous acid. Here we have nitrate. The ate gets changed to ic, that's nitric acid. Give you a couple more, and we'll be done for the night, man. We did so good tonight. I want you to try these. Try to name these, okay, using that naming convention. I will tell you this. Same thing. So with sulfate and phosphate, since it's sulfur phosphorus, you put the and the or back in it. Try these out. We'll go over them. You got this. Right. That is acetate. 8 goes to ic. It's acetic acid. This is sulfate. 8 goes to ic, but sulfic sounds dumb. We put the in, it's sulfuric acid. That's battery acid. Here we have phosphate. Again, 8 goes to ic, but phosphic sounds dumb. We put the in, phosphoric acid. So sulfur and phosphorus are the only exceptions in our naming conventions. We did it, folks.